These are some MCQs related to electric flux and Gauss law. Let's see the first one. There are four charges kept inside a closed surface. So inside a closed surface, plus 8 coulomb, minus 3 coulomb, plus 5 coulomb, and minus 10 coulomb is there. And we have to calculate the outgoing flux through the surface. So to calculate the first flux, we use this formula Q enclosed divided by epsilon naught. So let's calculate Q enclosed, which is equal to the total charge inside the surface. So it is plus 8 minus 3 plus 5 minus 10, which is equal to 0. So the flux should also be 0. So this is the answer. Next question. The electric charges are distributed in a small volume. Okay, in some small volume, electric charges are there. The flux of the electric field through the spherical surface of radius. So there's a spherical surface of radius 10 centimeter surrounding the total charges. So the flux is given phi equals 20 volt meter. Now we have to find out the flux of a concentric sphere of radius 20 centimeter. So we have another big sphere of radius 20 centimeter. So how will this electric flux change? So the electric flux actually depends upon the charge enclosed uh, and it doesn't depend upon the area of the closed surface. So it remains the same. So this is the answer. As you increase the surface area, flux will not change. So 20 voltmeter is the answer. Next question. Charge on a conducting metal sphere is present. So if there are any excess charges on a conducting metal sphere, that's any conductor, it will lie on the surface of the sphere only, because inside the electric field is a zero. According to Gauss' law, electric field of an infinitely long straight wire is proportional to. So there is a long wire. Suppose if this is a plus charged, okay, and the linear density is lambda equals q, that is charge per unit length. Now we can write the electric field as lambda divided by 2 pi epsilon naught r according to Gauss law. So we can see here E is proportional to 1 over r. So this is the answer. Next question. A conducting sphere of radius 20 centimeter is given a charge 16 microcoulomb. What is E at its center? So once again we have to understand the conducting sphere. It is there's a given it if it is given a charge q and E at its center will be 0, the charges will be distributed only on the surface. So E is 0 here. And the next one is a spherical shell of radius r has a charge plus q units. So the electric field due to the shell at a point. So we know the spherical shell, if it has a charge q and it behaves like the entire charge is at the center and it acts like a point charge. So the electric field due to this spherical shell, charged spherical shell, can be written as the electric field due to a point charge. So Q divided by R squared. So we can see from here E is proportional to R power minus 2. So we know that. And inside the shell, the electric field is 0. So inside it is 0 and it varies as R power minus 2 outside it. So as you go outside, It's going to, outside the sphere, it's going to be r power minus 2. What is the net charge on a conducting sphere of radius 10 centimeter? Okay. Conducting sphere of radius 10 centimeter, given that the electric field is 15 centimeter from the center of the sphere. So the electric, first let's draw this sphere. It's a 10 centimeter sphere, and the electric field from the center of the sphere is equal to 3 into 10 power electric field at some point. P is equals 3 into 10 power 3 Newton Coulomb. Okay, and it is directed inwards. Okay, now we have to find out what is the net charge on it. So we know that the net charge acting on it is can be calculated using the Gauss law. The electric field equation can be written as Q divided by R squared. Okay,